Another part of Coulomb's law, which says that the force of interaction between these two charged bodies is inversely proportional to the square of the distance of separation between them. Okay, let's look at this. These two charges are placed on a meter rule so that we can get the distance between them. Q1 is placed at the fourth mark, is placed on 4 centimeter. Q2 is placed on 7 centimeter. So the distance between 4 and 7 is 3. So the distance of separation between the centers of these two charged bodies is 3 centimeters. So how do you get that? You do 7 minus 4, that gives us 3 centimeters. Okay, so look at the amount of force existing between these two charges. The quantity of charge on Q2 is 8 microcoulombs. The quantity of charge on Q1 is minus 6 microcoulombs. So let's keep these charges constant, the quantity of charge constant. Let's increase the distance. Let's say that I move Q1 backwards to 3, such that the distance of separation between them has now increased from 3 centimeter to 4 centimeter. Q1 is now placed on 3 centimeter, Q2 is placed on 7 centimeter. So the interval between them, between their centers, is 4 centimeter. Now let's look at the force. You can see that what we're having now, the force exerted on Q1 by Q2 has reduced to 269.627 Newton. The same thing happens to the force exerted on Q2 by Q1. It's also reduced to 269.627 Newton. What does that prove to us? It proves to us that Coulomb's law of electrostatic interaction is correct, which tells us that if the distance of separation between two charged bodies is changed, either increased or decreased, there will be an effect on the amount of force they exert on each other. So if the distance is increased, since the square of the distance is inversely proportional to the amount of force they exert on each other. So if the distance is increased, the amount of force they are going to exert on each other will decrease. Let's say I move Q2 backward to a distance of 9 centimeters. So I place Q2 on 9 centimeter, place Q1 on 3 centimeter. The distance between their centers is 9 minus 3, and that gives us 6. So the distance of separation between these two charges has increased to 6 centimeter. And then if you look at it, you see that the quantity of force they exert on each other has decreased the more. This proves Coulomb's law that the force of interaction between two charged particles is inversely proportional to the square of the distance of separation between them. If I also bring this charge close, let's say I bring Q2 closer, and then also bring Q1 to 5. Now Q1 is placed on 5 centimeter, Q2 is placed on 7 centimeter. The distance between their centers is 7 minus 5, which is 2 centimeters. And now you see they are closer to each other. I have kept the quantity of charge on each of them constant. The quantity of charge on Q2 is 8 microcoulombs. The quantity of charge on Q1 is minus 6 microcoulombs. Now look at what happens. The force of the interaction between the two charges, the force they exert on each other has increased. You can see it is now 891.327 Newton. So you can see that there are factors that affect the force of interaction between two charged particles. One of the factors is the quantity of charge on the charged body. Another factor is the distance of separation between them. So how do these factors affect the amount of force that the charged particles exert on each other? This is how they affect it. An increase in the quantity of charge on the charged bodies increases the amount of force they exert. So there is a direct relationship between the amount of force the charged bodies exert on each other and the quantity of charge on the charged bodies. But for the distance of separation, if I increase the distance of separation, the force decreases. So there is an inverse relationship. What happens is that if the distance of separation between the charged bodies is increased, as I've increased this, you keep seeing that the force keeps reducing. So if the distance of separation between two charged particles is increased, the less the force the charges will exert on each other. That's what Coulomb's law states. Okay?